Apologies for the late start. So good morning, good afternoon, and good evening from health. Uh, Joining our Pulse of Networks webinar, two, shifting to 5 nines in SLA to build better experience in 5G. My name is Gary Augustin. I'm the CEO of Creanord, and I'm here at Austell, Senior System Engineer.
Hello.
Okay, so as mentioned, this is our second Pulse of Networks webinar with a special focus on 5G. Actually, we'll be doing two webinars about 5G. The first one, which is today, will focus on business side of things. What are the market drivers, use cases, value propositions? So after today's webinar, I hope you will have an idea why active service assurance is important in 5G. The next webinar will focus on the technology, network architectures, and the technical side of things overall. And that will give you an idea how service assurance needs to be deployed to fulfill the promise of 5G. So agenda for the next 25 minutes is the following. So I'll start the presentation by going through the background of 5G, what are the main drivers, launch stages, and some data points for the first 5G deployments. Then we will cover who are the main revenue generators for 5G, what are the main use cases, and what are the performance and SLA requirements. And in the end, we will talk about the focus areas to reach the 5 nines availability target. So now some background. I am certain that many of you have seen this or similar slides earlier. So what are the main technical drivers, 5G targets? What is the main promise of 5G? So 5G will provide enhancements in three main different areas. Ultra-reliable low-latency communication services, enhanced mobile broadband, and massive machine-type communications. Those are the three main areas in 5G. So 5G is supposed to have significantly lower latency than 4G. In certain use cases, the latency should be as low as 1 millisecond. So 3GPP actually has even stricter target where the latency should be as low as 0.5 milliseconds. 5G will also provide significantly higher traffic capacity, and the data rate should peak even up to 20 gigabits for a single user. Overall, the common denominator most of these drivers is better network performance, 5G is faster, provides better quality, provides better user experience than 4G or LTE. And it can be used in various different use cases as well. So those were the main targets, but are those only promises? So any feedback from the real deployments? As of today, more than 100 commercial 5G networks have been launched worldwide. North America, Europe, certain countries in the Middle East and Far East have already deployed 5G technologies. Also, hundreds of other operators globally are investing in 5G. So the deployment pace seems to be fast, comparable or actually faster than the previous mobile technologies like 4G, which is good. So the feedback from the first deployments is positive. Speed tests are providing fantastic results, both in terms of throughput and latency. So OpenSignal actually conducted a study earlier this year, which proved that 5G isn't all about promises. The results compared to 4G are significantly better. So according to OpenSignal, 5G was able to provide even 14 times higher download speeds than 4G, which is fantastic. And if we look at the impact on the whole network, so 5G estimated to explode the traffic volumes. Even earlier, the volumes per user have increased a lot. So like Finland is leading this statistic with Taiwan, where the average mobile data consumption per user is much more than 1 gigabit per day per user. Actually, when the first LTE network started in the year 2010, the total mobile traffic was like 8,000 terabytes per day globally. When the first 5G network started in 2019, the mobile data traffic of even a small country like Finland was the same, 8,000 terabytes per day. So Finland also generates more mobile traffic as global fixed internet traffic in the year 2001. And if we are believing like Finnish incumbent operator Elisa, 5G will dominate the traffic volumes already in the near future as well. So the volumes will continue to grow. So 5G definitely is real. It can provide better speed and quality than 4G. So are all consumers then anxiously were buying the 5G services? Actually, you can find a lot of information about this on the internet. There are several analyst reports like the one shown on this slide, done by Analysys Mason and GSMA Intelligence. So consumers are really interested in 5G-enabled services. However, they really aren't willing to pay that much extra. Perhaps the first operators in the market have been able to get a small premium, which really hasn't resulted in the better profits due to the higher costs, such as in marketing. So just reading also the news from the internet proves that the conclusion of these reports, like Verizon, AT&T, Vodafone, Orange, Telstra, all of them have started to offer 5G services with no extra cost. Of course, there are like techies who want to have the best fixed wireless access, highest possible speeds, and are willing to pay a premium. But generally, the ARPU is more or less the same than with 4G. There are certain services which might generate some additional revenue, though. Gaming and virtual reality are promising use cases for that. However, these use cases are quality-wise the most challenging with the network perspective as well. Those require high bandwidth and extremely low latency. So one example here is La Liga, the Spanish football series, who would like to broadcast each game live using 5G connected VR cameras. Really nice idea, especially now during the COVID-19 pandemic. So user would be able to feel the experience of really being in the stadium. So La Liga would buy a 5G slice with really high capacity uplink, and network, they would buy a network slice from the local 5G provider. The latency needs to be super low, so multi-access edge computing server would be located really close to the stadium, and they would be selling this like $19.99 per month. So there are these kind of growth opportunities with consumers, but those also will require highest possible quality. So the target audience for 5G cannot be consumers only. Someone else needs to generate the profits. And that market is the industry market and enterprises. And the quality expectations on that market are totally different. Consumer market, like 4G, hasn't seemed to be really reliable. There are several studies that have shown that uptime on the 4G network has been even much less than 99%. Consumer market on a high level is based on the best effort. However, like you can see from the following slides, industry market requires highest possible quality. 5G enterprise services are business critical. Quality, security, availability needs to be the best. The network availability will be 5 nines, in certain use cases, even 6 nines. So its consumer market is based on best effort. Industry market will be based on service level agreements, SLAs. So the shift from 99% network availability to 5 nines is huge. It's really huge. 99% availability means the downtime is 87.6 hours per week per year. 5 nines mean that the downtime is only 5.2 minutes. And since certain use cases require 6 nines availability, the downtime can be only 32 seconds per year. So it's a massive change. So this shift requires that quality is not an afterthought. We will build the network first and worry about the quality later. That kind of attitude won't work. 30-second downtime means that the quality needs to be part of every network design plan from the day one. And GSMA Intelligence actually did a research about this. They interviewed a high number of service providers, and the results confirmed the statements from the last slide. So enterprise services are the key for 5G success. Enterprise services will generate most of the revenue and profits by the year 2025. So having said that, SLAs Hard SLAs are definitely required to sell 5G, and this is something new. SLAs have been there earlier, especially in North America, but in the 4G, the SLA's role wasn't as strong as in 5G because 4G is best effort. But there are also a few additional points which are important. So first of all, live reporting will be a must-have capability. Monthly reports won't be sufficient. Enterprises need to know in real time the status of the service that they are buying. Another important point is the scope of the SLAs. Network-centric SLAs or quality of service-based SLAs aren't enough. Also, the service performance, application performance needs to be secured as well. So enterprises are critical for 5G, and the quality and SLAs play an important role in selling 5G to different industries. So there's a long list of different applications, target applications for 5G. However, here I focus only on a few most important ones. Mainly private networks require ultra-reliable low latency communication services. So the private networks on a high level can be implemented in two different ways. The first method is to buy a network slice, totally separate slice from the service provider. So as an example, this is what Nokia, Deutsche Telekom had done with the port of Hamburg. Other application or use cases could be like public safety, where let's say police would buy a separate slice from the local 5G provider instead of having a totally separate Tetra network. Another way to provide private networks is to buy a dedicated local network as well. So many utility companies have already done this, car manufacturers, mining companies, and there seems to be a great demand for that, like in Germany, where the high number of licenses have been granted in a short period of time. Other use cases for ultra-reliable low-latency communications could be like wireless microgrids, remote patient care, or transportation. Actually, this is also getting a lot of interest. So V2X doesn't only mean self-driving vehicles. The near-term use case is actually different. Like Volvo is doing, like Volvo's large animal detection system can spot and identify large animals, understand their behavior, and stop the car before colliding with the animal. So here in Scandinavia, moose is a typical suspect, and every year many people die because of moose accidents. That solution is still based on radars, but going forward, the cars will get information from the network, which will make driving safer than it is today. Overall, ultra-reliable low-latency communication requires lowest possible latency and best possible quality and hard SLAs. So let's talk for a while about the performance requirements. And so in the 5G, visibility on the network needs and will be different compared to 4G. So in the 4G, the connectivity was typically monitored from the gateways to the eNode Bs. If passive monitoring data was used, the data was typically aggregated, providing the visibility to certain region, domain, or network elements. And even today, 5 to 15 minute average performance data is used, and then customers are getting their monthly reports on Excel sheets or from our portals. This will change in 5G. So 5G required to have visibility to the endpoint. Enterprise customer could be an end device, let's say a robot, from the cloud. So the connectivity will be from the cloud to the endpoint, cloud to the end device. Aggregated data and passive monitoring info is still important, but it needs to be complemented with the detailed information about the network, truly end-to-end, including all different network segments. This kind of average data isn't sufficient. The data needs to be really, really granular, showing all the microbursts and everything which can have an impact on the business critical traffic. And definitely monthly reports won't be enough. Enterprise customers will require real-time reporting over APIs. And this is needed for two different reasons. First, to increase the trust among the enterprise customers, and second, secure the highest possible network and application performance. So this is how the network visibility requirements are changing. Enterprises, so they want to have visibility on, let's say, on the following things. So they want to monitor all the possible quality service KPIs, like ultra-reliable low-latency communication requires lowest possible latency, but naturally packet loss deter and have an impact on user experience too. On the network slices, the throughput definitely needs to be measured and guaranteed. Enterprises also want to know if the service that they are buying is definitely meeting the 5 nines target or 6 nines target. And last, quality experience needs to meet the highest standards too. So these are the things what the enterprises require from the service providers. Where the measurements will take place. So like mentioned earlier, many of the connections do not traverse all the way to the core. Certain applications, like in the La Liga use case, are served by the multi-access edge computing servers, which are close to the users to minimize the latency. So the connectivity to and from the edge or from the MEC servers is important. Of course, the connectivity to the 5G core network or 5G cloud needs to be secure too, obviously. And customers who are buying the end-to-end slice, it needs to be assured end-to-end. It is absolutely critical. And how the reporting will be done won't be Excel sheets on a monthly, which will be sent on a monthly basis. They want to have detailed and really granular network info in real time over streaming interfaces such as Kafka, like what Trianode is typically using. And this will be then highlighted in the new SLAs. Every SLA, every slice will have different KPIs. Service providers cannot have just 1 or 2 or 3 different SLAs like in the past. In the era of the network slicing, the number of SLAs will explode. Every network, every slice can and probably will have different quality criteria and will have a different SLA as well. So, but typically the SLAs will have 3 different main components. There's the quality service component. That is something that has been traditionally been used, even though the throughput and link utilization will play a higher role in the future, mainly because of network slicing. However, the quality of experience will be something new. There have been SLAs where quality of experience has been requested, but it will be more important going forward. How are my applications now doing? What is the mean opinion score for the voice over IP? Overall service availability. So the QoE definitely will be important in the future SLAs. And then this kind of operational level agreement, it isn't really anything new, but the importance of the operational level agreement will increase when selling this kind of business critical services to enterprises. Unfortunately, the outage trend is going to a totally wrong direction. So it should be going down, it's going up, despite all the investments on the different fault and performance management systems. Outages are increasing, so according to the heavy reading, 46% more outages during the last 3 years. And another issue is that due to the complexity in the network, like virtualization, multi-vendor environments, etc., the outages are really difficult to resolve. It takes ages to even isolate these issues. So thus, new tools and processes will be needed. And also still today, many operators rely on passive monitoring, fault management systems, etc. So let's say information which is coming from the network elements. These systems can reveal real outages that everybody can see. So network is down, traffic doesn't go through. However, 98% of issues are invisible. Network is just slow. And in the 5G world, also these invisible issues will be tracked. These invisible issues need to be tracked. So end customers are today suffering from these issues every single day. And that's why active assurance will be needed. It can complement the data coming from the passive monitoring platforms. So actually this slide was shown already in the first webinar, but a short recap. So why active service assurance matters. It matters also in 5G because 3 different reasons. First, it provides required granularity. So enable service providers have a visibility to short-term bursts and packet loss in order to isolate different issues. and that this bursty traffic in is important because it can cause traffic loss to critical control and signaling traffic. And the granular data is also needed for accurate traffic engineering designs. So there's an example. So that is some data from the live network from one of the base stations in one of the capitals in Scandinavia. So the picture on the left-hand side shows 5-minute average bandwidth data, which peaks at 675 megabits. Nice curve. However, the 10-second streaming data curve peaks at 1.5 gigabits continuously. So totally different traffic profile, and that could cause easily traffic loss to business critical traffic. So granularity is important. The other one is like the accuracy for confidence. You need to have the confidence that the information you have is real. So as an example, 1 millisecond latency target require microsecond level measurement accuracy. And if you're using some software-based solutions, not hardware timestamping, those solutions might show problems which actually aren't real, and you fail to see problems actually you should. So this kind of a hardware timestamped, accurate and reliable data is critical. And last, the active service assurance can enable proactiveness and automation. So service providers can proactively follow the network quality with active service assurance, fix minor issues before they become major. It also enables automation. So there are many studies which are showing that today, 59% of respondents were enabled to automate due to the lack of reliable network data. And this is something where active service assurance definitely can help. So this can help and improve the situation with these invisible quality issues that customers are experiencing continuously. And I also mentioned earlier that networks are becoming complex. It's true, really true. If you look at the mobile network diagrams, there are a number of different interfaces. It's huge. Interoperability between different mobile generations needs to be supported, etc. It is challenging. And SD and NFV with different orchestrators, VNF vendors, VIMs, which are coming from different vendors, need to be interoperable. They don't always interoperate, and that will generate additional complexity in the network. And last but not least, number of network elements will explode, at least in the dense, in urban areas. So number of base stations, small cells, aggregation locations will be tens of times higher than today. And again, active service assurance will help to improve the situation, improve the visibility to the network, and that what is happening and where. So how do we meet this 5 nines target? So in the complex world, make sure that the service meets the SLA criteria before the service launch. Automate that so that every new site, every new customer location will be validated. It is cheaper to fix the issues before the service launch versus troubleshooting complex network issues with live traffic. So burst certificate, like a report coming from the service activation tests, is kind of your insurance the service has been up and running. It works. So it is important to test the connectivity and the application layers before the new applications or services are launched. So do the 1564 tests, validate the UDP connectivity, use RFC 6349 to make sure that the TCP traffic works as well. Do it right at the first time. That is important. 2, continuously measure the network. Every end-to-end connection, every segment, both quality of service and quality of experience. We could say more the better. More test traffic, more invisible issues and anomalies can be detected. And then 3, when you have this reliable, granular, and accurate network data available, then you can use your management tools to ensure the high availability. First of all, the predictivity is key. So service assurance data, active service assurance data can provide warning signs, trend information about coming issues. You can fix these small issues before they become major, and this way improve the availability of the network. When complemented with, let's say, artificial intelligence or machine learning tools, the service providers can even operate their networks even more proactively. And then two, automation will be definitely mandatory in the large deployments. So with large main amounts of reliable network data, the adaptive networks can be done. And it also enables quality improvements without increasing the headcounts in the NOC. So automation definitely is important as well. And then last, number four, so when you have confidence on your network, then your customers will trust it too. So you can remote the service performance as is, do it in real time, which improves the customer intimacy and increases the openness. So these are the four important topics to assure the 5G promise. So Creanord is about this. It is exactly about this. So our Creanord solution enables, first of all, validation of new services, meaning service activation testing, generating these birth certificates. Two, it enables network and experience testing end-to-end from multiple layers from layer 2 to layer 7. It does provide predictive capabilities, dashboards, and reports about the network and customers. It also provides interfaces with third-party platforms like big data systems, provisioning systems, performance management, and SDN orchestrators for automation. And we can also provide customer portals, streaming data integration for real-time SLA reporting. So Creanord is about what we have been talking in the previous slides. Our platform is called PulseSure. It's all-in-one solution for active service assurance, and it actually supports two main components. So PulseCore is the management platform providing quality dashboards, SDN orchestration integration, streaming data integration, performance monitoring reporting, etc. And it requires data to operate, and you will get the data typically from our pulse sensors, so from our network quality measurement devices. And we have a portfolio of sensors available, both virtual and physical sensors, which are coming in different sizes, small, medium, large, fully depending on the customer need. And just to conclude my presentation, here are the key takeaways. So I think there are six different things to consider, six different things to remember when trying to reach the 5 nines availability. So the key takeaways are, so you need to understand first the true quality and customer experience. Basically implement active and passive testing for layer 2 to layer 7 visibility. Preferably the whole network needs to be instrumented. More data the better, and this requires a range of virtual and physical probes. And three, and that 5G will try new SLAs for enterprise customers. Quality service, quality of experience with different target KPIs, and really differentiated quality. That is important. And the reliable network data, all the birth certificates, predictiveness will improve your confidence that the services work. And when you have the confidence on the service, then your customers will trust you too. And that can be strengthened by the real-time APIs or real-time SLA reporting. And last, we cannot forget the costs, and those can be managed by automating network operations. At the same time, we will also improve the quality. So this concludes my presentation, and I believe we do have a few minutes for questions. So.
Okay, very good. Jari, can you hear me?
Yes, I can.
Okay, very good. Let's see here now. The first question I have here is, what will SLAs for business services look like in the future? Maybe I could answer that one. I think when you're looking at SLAs, so they will in future still contain the same KPIs that we have today, of course, related to the network performance and mean times to repairs and so forth. But as we touched on in this presentation, what is key there is to take it one level further as the businesses start using cloud services and so forth. So the quality of experience is really critical. So there's going to be additional quality of experience KPIs added to really describe how the users of the service are experiencing it. So that's a very key ingredient. And the other key ingredient is really that when we have been used to getting monthly report or regular reports on how the network performed, is it's in the future it's going to be much more real time. So you need to offer the real time status directly to the customer in real time, and not just as regular reports. So let's see here. Then I have one here. Are there 5G networks where you have deployed your solution today? So maybe that's for you, Jari.
Certainly, there are several. We do have 5G deployments in many networks. In Scandinavia, we have deployments in Middle East, Asia, and our idea actually is cover some of the experience we have learned from those deployments in the next webinar as well. A little bit more from the technical angle then.
All right, and then I have one here. Can the data you are measuring and machine learning combined predict network outages? So definitely in our system we have features to predict these type of outages. So we, for instance, are looking at the traffic conditions and the history, and looking at how the traffic has performed, and then predicting how it's going to perform in the future. And if you have if your traffic is then somehow differing from the normal behavior, we're going to inform you. And it's also possible to get warnings before the service levels degrade so much that it's showing up for the end users. So we warn you before you are actually your end users gonna react to the problem, so you have time to fix it before. So it's definitely something that we have in the system. And in addition, we also in many cases export our data to big customers also have their own systems for analysis, and we have the capabilities through the Kafka interface to export all of our details, and then the other systems will then combine it with log files and so forth to do further troubleshooting. So it's both worlds actually. So let's see, are there any other questions? Yes, I have one here. Is it possible to monitor 5G SLAs based on network slicing? Yeah, absolutely. So definitely that's one of the things that we are doing in our system. We we have capabilities also for measuring the user experience for the mobile network, and also in the case of network slicing. And then I have one here. Please explain special training and manpower KPI. I'm not sure what is meant by that. That question, could you, Arif, could you elaborate a little bit more in the chat on your question there? Then we have, in the meanwhile, we have one from Juan. What is the key difference between Granord and equipment provider management software like Huawei? So is that for you, Jari, maybe?
Perhaps Klaus, you can take that.
Okay, so one of the when you are comparing, for instance, to the equipment providers, is that when we are looking at our focus, we are really focusing on the accuracy of the measurements and also the range of measurements that we provide, so that you get a full picture. In case of the network element vendors, so their focus is perhaps a bit more on other things. So you are not getting a full suite of measurements. So that's really the big difference. And what we are seeing, the accuracy is definitely one thing. We have really focused on delivering the microsecond level accuracy, and also the scalability that you can cover a large part of your network. So that's these are really the main differences, and of course also in terms of the features. So we not only measure the network level performance, but also go up to the quality of experience level with our solution.
Pat, you can say I can say a few words about the scalability. Is like typically, let's say the router vendors, so equipment providers, so they support fairly low number of, let's say, TWAM sessions per router or per box. We are talking about hundreds of sessions per device. If you look at some of the mobile backhauling 5G deployments, you want to measure connectivity from the central locations to the base stations. So you can have easily like tens of thousands of sessions from one single location to the endpoints. And it just doesn't make any commercial sense to have to stack routers for measurement purposes only. So like there are several technical reasons like accuracy, larger, higher number of measurement capabilities, but this also makes commercial sense to have dedicated devices for quality assurance.
All right, I think that's all we have for today. Okay, so I think that's all questions we have here today. So should we wrap it up?
Yeah, I think we can. So thank you again for joining, and I hope to see you in the upcoming events again. So the next one will be in a few weeks from now with the 5G focus again. Now we'll anyway spend a little bit more time on technical aspects, not much on the today on the business side. So thanks, and have a good day.
Okay, thank you. Bye.